Question number 6. This question is from work, power, and energy. A car of mass 1500 kg is pulling a trailer of mass 750 kg up a straight hill of length 800 meters inclined at an angle of sine inverse 0.08 to the horizontal. This is inclined plane motion. The resistance to the motion of the car and the trailer are 400 Newton and 200 Newton respectively. The car and the trailer are connected by a light rigid tow bar. The car and the trailer have speed 30 meter per second at the bottom of the hill and 20 meter per second at the top of the hill. Part A of this question is use an energy method to find the constant driving force as the car and the trailer travel up the hill. So first of all, this question is from work, power and energy. First of all, we will make a diagram so we may understand this. This is a horizontal surface making angle sine inverse 0.08. This is the angle. Angle is given, that is sine inverse 0.08. So we can say that theta is equal to sine inverse 0.08. From here we can find the value of sine theta, that is 0.08. That this is trailer of mass 750 kg. This is a rigid tow bar. This is a car of mass 1500 kg. This is car, this is trailer. We represent the forces, tension and opposite direction of the two tensions. This is the bottom and this is the top of the hill. This is the bottom of the hill. This is the top of the hill. This is trailer, car, tow bar. tension and the straight hill of length 800 meter. This is this distance is 800 meter. Resistance on car is 400 Newton and the resistance on the trailer is 200 Newton. Speed at the bottom is 30 meter per second. Speed at the top is 20 meter per second. Now we have to find use an energy method to find the constant driving force as the car and the trailer travel up the hill. We have to find the constant driving force as the car and trailer travel up the hill. So work energy relation is this: work done. I am writing in short form. WD mean work done by driving force is equal to work against friction. I am representing here friction by a small alphabet F. This is work against friction plus change in mechanical energy. Delta ME mean change in mechanical energy. So work done by driving force will be F into D. F is we have to find driving force into D. Distance is 800 meters from bottom to top. So work done by driving force uh, F into D. D is distance is 800 meter. Work against friction. Work against friction F into D again. Now we will add these two frictions. 400 plus 200. Friction is 600 and distance is same from bottom to top, that is 800 meter. So we are writing here 600 resistance force. We are adding both the resistance forces 400 and 200 opposing the motion of the system. 600 into 800 distance plus change in mechanical energy. Now first to find the change in mechanical energy, first we will find the mechanical energy at the bottom and the mechanical energy at the top. But we know that mechanical energy is the sum of potential energy and kinetic energy. First we will find potential and mechanical energy at the bottom. Let this is equation number 1. First we find mechanical energy at the bottom, that is mechanical energy is potential energy plus kinetic energy. Potential energy because at the bottom there is no height, so potential energy will be 0. So because potential energy is due to the height of the particle, but there is no height at the bottom, so potential energy is 0. Kinetic energy 1 over 2 mv square, 1 over 2 m Mass, we will add the mass of both the car and the trailer. Mass of the car is 1500 and mass of the trailer is 750 kg. We are adding, so we have mass is after adding 1500 and 750 we get 2250 kg. To v square, v speed at the bottom is 30 meter per second, 30 square. After calculation, we get this 1012500 joule. This is mechanical energy at the bottom. In the same way, we will find the mechanical energy at the top. Again, potential energy plus kinetic energy. Potential energy, to find the potential energy, we have to find this height. We can easily find this height. Let this height is h. Now we will find this height h using a trigonometric ratio. Perpendicular over hypotenuse is equal to sine of this angle. The angle is given. So we can find height from here. Perpendicular over hypotenuse is equal to sine theta. Sine theta is 0.08. From here height is equal to 64 meters. So potential energy will be mgh. M is 22 total mass of trailer and car. Mg is 10. H is just we have found, that is 68, 64 meter. 64 plus kinetic energy 1 over 2 mv square. 1 over 2 m is total mass, that is 2250. V square, V at the top is 20 meter per second. So we are taking it square. 20 square. After calculation, adding these two terms, after calculation we get this uh, we get this 1440000 plus 450000. So mechanical energy at the top will be, adding these two terms, we get 1890000 joule. This is mechanical energy 1890000. This is joule. This is mechanical energy at the top. Mechanical energy at the bottom is 1012500 joule. So we will write here change in mechanical energy means final mechanical energy minus initial mechanical energy. We are writing here. So from equation number 1 we get, from equation number 1 we get F 800 is equal to 600 into 800 plus change in mechanical energy final minus initial mechanical energy 1890000 minus 1012500 So from here we can find the value of this F, that is driving force. So driving force will be 169.6.9. So by rounding off, we can write F is equal to 1700 Newton. This is the answer. 1700 Newton is the driving force as the car and the trailer travel up the hill. Now next part B of this question is, after reaching the top of the hill, the system consisting of the car and the trailer travels along a straight road, level road. The driving force of the car's engine is 24 Newton. Now driving force of the engine is given, that is 2400 Newton, and the resistances to the motion are unchanged. So resistances on car and trailer are unchanged, remains the same as in the above part. Find the acceleration of the system and the tension in the tow bar. So now the car and the trailer are moving on the horizontal level. We are making in the same diagram. This is the horizontal level. Car and the trailer. This is car. This is trailer, and this is car. This is tow bar. Tension. Both tensions are in opposite direction. Now we have to find the tension and the acceleration. Resistance same. On the trailer resistance is 200 Newton. On the car resistance is 400 Newton, acting in the opposite direction of the movement. Now we will make two equations for both trailer and the car. Now for car, equation of motion will be, now the driving force clearly given, that is 2400 Newton. So and the opposing force will be tension. Both are tensions in opposite direction. For car, equation will be 2400 minus tension minus 400, that is resistance force, is equal to MA. Now in this case we are only consider the car's motion, so we are taking the mass of only car, MA. Now let this is equation number 1. Now for trailer, equation will be, for trailer equation will be T minus 200 T is tension and 200 is the frictional force, resistance force, tension in this side and opposite in the opposite direction that this friction. So equation net force will be T minus 200 is equal to MA. Mass of the trailer is 250, 250A. Let this is equation 2. Now we will solve these two equations 1 and 2 simultaneously. Solving these two equations simultaneously, we get acceleration and tension. So from equation number 2, we can write equation number 2 is that T is equal to 200 plus 750A. Putting this value of T in equation number 1, here equation number 1 is uh, equation number 1 is 2400 minus T minus 400 is equal to MA 1500A. Putting this value of T here, we get 2400 minus T 200 plus 750 A minus 400 is equal to 1500 A. From here we can find the value of acceleration. Simplifying it, we get 2400 minus 200 minus 750A minus 400 is equal to 1500 A. Now collecting the like terms, we get 2400 minus 200 minus 400, we get it 1800 is equal to, now this A term will move to right, becomes a sign become plus. So we are adding these two terms, we get 20 to 50 A. From here, acceleration will be 0.8 meter per second here. This is the acceleration in the system, and now we put this value of acceleration in this equation number 2. Now T becomes from equation number 2, from equation number 2, T will be 200 plus MA. MA is 750 and A is 0.8. After calculation, we get tension is equal to 800 Newton. This is the answer. This is the tension and this is the acceleration.